We've all seen it in the movies. The suspense builds, the music crescendos, and the villain, with a sinister glint in his eye, decides it's time to dispose of the evidence. A bad guy needs to get rid of a body, fast. Under the cover of darkness, he drags the lifeless form to a secluded spot, ensuring no one is around to witness his nefarious deed. He pulls out a vat of bubbling acid, a sinister grin spreading across his face. The liquid hisses and steams, promising to erase all traces of his crime. The message is clear: acid equals a clean getaway. The villain looks around nervously, making sure no one is watching before proceeding with his plan. But is this Hollywood magic or rooted in real science? Can a simple chemical concoction truly make a body vanish without a trace? Can acid really make a body disappear without a trace? The reality is far more complex and less glamorous than the silver screen suggests. The answer, like most things in science, is more complicated than a 2-hour movie. While certain acids can indeed break down organic material, the process is neither quick nor clean. The truth is, dissolving a body completely in acid is much harder, messier, and smellier than the movies make it seem. The process involves a lot of preparation, specific conditions, and even then, it's not foolproof. It's not as simple as dropping a body in a bathtub full of acid and watching it vanish. The acid needs to be strong enough, the temperature must be controlled, and even then, it takes time. While certain acids can break down organic matter, the process is slow, inefficient, and leaves behind a lot of evidence. Bones, teeth, and other resistant materials often remain, making it far from the perfect crime. In reality, forensic scientists can often detect the use of acid and trace it back to the crime scene. The chemical residues, the distinct smell, and the partial remains all serve as clues. So while Hollywood loves the dramatic flair of acid disposal, the truth is far less convenient for any would-be criminal. Science, with all its complexities, ensures that the real world is not as easily manipulated as the movies. Movies and TV shows often take liberties with science, and the depiction of acids is no exception. The most common acid portrayed is hydrofluoric acid, often shown eating through bathtubs and dissolving bodies in minutes. While hydrofluoric acid is indeed corrosive, it's not as instantly powerful as Hollywood portrays it. Other times, movies invent fictional superacids that can dissolve anything instantly. These acids are pure fantasy, existing only in the realm of special effects and dramatic license. In the real world, even the strongest acids take time and specific conditions to break down organic matter completely. Acids are substances that release hydrogen ions, H+, when dissolved in water. The strength of an acid is measured by its pH level, with lower pH values indicating stronger acidity. While many acids can irritate skin and damage materials, only a few are strong enough to break down complex organic matter like human tissue. Strong acids, such as sulfuric acid and hydrochloric acid, can hydrolyze proteins and fats, the building blocks of our bodies. However, this process is not instantaneous. It requires time, heat, and a large volume of acid to be effective. Additionally, the reaction produces heat and noxious fumes, making it a dangerous and unpleasant process. In reality, dissolving a body in acid is a slow and inefficient process. It's not like dropping a sugar cube in coffee, it's more like trying to dissolve a Thanksgiving turkey in a bathtub full of vinegar. Even with strong acids, the process would take days, if not weeks, and would require constant monitoring and replenishing of the acid. The reaction would also produce a foul odor and release harmful fumes into the air. The acid would react with different tissues at different rates, leaving behind a gruesome soup of partially dissolved flesh, bones, and other bodily fluids. It's a far cry from the clean and efficient disposal method often seen in movies. One of the biggest misconceptions perpetuated by movies is that acid dissolves everything, leaving no trace behind. This is simply not true. While strong acids can break down flesh and muscle tissue, they struggle to dissolve bones and teeth, which are much denser and more resistant to acid degradation. In fact, forensic scientists often use acid to help identify human remains. By carefully dissolving away the soft tissues, they can expose the skeletal structure, which provides valuable information about the deceased person's age, sex, and potential cause of death. Even if a body is partially dissolved in acid, bones and teeth can provide crucial evidence. Section 6. Safety first. Acids are not for amateurs. It's crucial to remember that acids are incredibly dangerous substances. Handling strong acids requires specialized knowledge, protective equipment, and strict safety protocols. Even a small splash of concentrated acid can cause severe burns, blindness, and respiratory problems. Attempting to dissolve a body in acid is not only illegal and unethical, but also incredibly dangerous. The fumes alone could be lethal, and the risk of spills and explosions is significant. It's best to leave the handling of strong acids to trained professionals in controlled environments. Section 7. The law is clear, no dissolving allowed. While the science of dissolving bodies in acid is fascinating, it's essential to understand the legal ramifications of such an act. The process, often depicted in movies and TV shows, might seem like a foolproof way to eliminate evidence, but reality is far different. The law is unequivocal on this matter. Tampering with a corpse is a serious crime in most jurisdictions, and attempting to dissolve a body in acid would likely result in severe criminal charges, including desecration of a corpse, tampering with evidence, and potentially even murder. The legal system treats these offenses with the utmost severity, reflecting society's respect for the deceased and the importance of justice. Law enforcement agencies have sophisticated forensic techniques at their disposal, and even a partially dissolved body would leave behind a wealth of evidence including DNA, fingerprints, and other trace materials. Modern forensic science is incredibly advanced, capable of uncovering the smallest clues that can lead to a conviction. The idea that acid can completely erase all traces of a body is a myth. In short, attempting to dispose of a body in acid is not only morally reprehensible but also a surefire way to land you in serious legal trouble. The consequences are severe, and the likelihood of getting caught is high. It's a path that leads not to freedom, but to a prison cell. The law is designed to protect the dignity of all individuals, even in death, and to ensure that justice is served. Section 8. Ethics matter, respecting human remains. Beyond the legal consequences, there's a fundamental ethical obligation to treat human remains with respect and dignity. Every human life has value, and disposing of a body in such a callous and disrespectful manner violates basic human decency. Proper burial or cremation allows for closure and grieving for loved ones, and acknowledges the value of a human life. Attempting to erase a person's existence by dissolving their body in acid is a deeply disturbing act that disregards the sanctity of human life and the importance of respectful mourning. Section 9. Separating fact from fiction. Acids and the movies. So, while the image of a body dissolving in a vat of acid might make for a compelling movie scene, it's crucial to separate Hollywood fiction from scientific reality. Movies often exaggerate or completely fabricate scientific processes to create drama and suspense. This is especially true when it comes to the portrayal of acids and their effects. Dissolving a body in acid is far more complicated, messy, and inefficient than movies portray. In reality, the process would require a significant amount of time, specific types of acids, and controlled conditions to even come close to what is shown on screen. Moreover, the logistics of obtaining and handling such dangerous chemicals are far from simple. It's also incredibly dangerous, illegal, and ethically wrong. The use of acid in such a manner is not only a criminal act but also poses severe risks to the person handling it. The fumes alone can cause serious harm, and improper disposal can lead to environmental damage. The next time you see a movie where someone tries to get away with murder using acid, remember that real life is far more complex. The legal and ethical implications are vast, and the scientific reality is much less glamorous. Hollywood often simplifies these scenarios for the sake of storytelling, but it's important to approach such depictions with a critical mind. Science tells us it's not that easy, and our laws and ethics tell us it's never the answer. Educational institutions and scientific communities work hard to ensure that the public understands the real-world applications and limitations of chemical substances. They emphasize safety, legality, and ethical considerations in all scientific endeavors. Let's leave the acid to the scientists and focus on treating each other with respect, both in life and in death. By understanding the true nature of acids and their proper uses, we can appreciate the importance of science in our daily lives and the ethical responsibilities that come with it.